circuit shown into single equivalent current source. You have to convert it into single current source, not voltage source. It's a single current source. And here the given problem is actually it consists of three practical voltage source. This is one practical voltage source in series resistance, voltage source in series resistance, voltage source in series resistance. So three voltage sources are connected in this pattern. So we need to convert it into single current source. So in series we can add the voltages. In parallel we can add the currents. Here two parallel paths are there. In parallel we can add the current. So we have to convert these two voltage sources. We need to convert it into current source. So V is equal to IR, I is equal to V by R. So 12 by 4 is 3 and current direction is minus 2 plus. This is also minus 2 plus. Both currents will go upwards. So 3 amps going upwards. Same 4 amps you have to connect here. And 18 by 16 by 8 is 2 amps going upwards and same 8 you have to connect here. Now we can add 3 and 2 5 amps, 3 and 2 5 amps upwards, and 4 and 8 parallel, 4 and 8 parallel, 4 into 8 divided by 4 plus 8. Okay, it is 2.67. Now we have voltage source in series with current source. We have voltage source in series with current source. In series we can add only voltages. So here we need to convert this one back into voltage source. You have to convert this 2 into 5 into 2.67. 5 into 2.67 is 13.3. And you have to connect same 2.67 in series here. And this is as it is, no changes here. Now between A and B we have two voltage source. We have two voltage sources are in series. Starting from A, plus minus both will be added. 8 plus 13 is 21.33 and 2 is in series with 2.67. So it is 4.67. The answer is 4.67 is the resistance and 21.33 is the voltage. But the question is you need to find single current source. So again you have to convert this voltage source into current source. So 21 point V is equal to IR, I is equal to V by R. So 21.33 divided by 4.67 is 4.56. Minus to plus, direction of the current is from minus to plus upwards, that is towards BA side, and same 4.67 you have to connect across parallel to it. So this is this problem, and I think one more problem you can study. This is also same type. You need to convert this one to current source, this one to current source. You have to add those two currents. Okay, and two voltage sources are in series, we can add it. Here also they ask you to find single equivalent current source. So net equivalent current source is this. So let us have one more problem based on source transformation technique. This is a problem on dependent sources. There is a dependent source. How to identify it is a dependent source? Diamond shape. There is a diamond shape. Using source transformation technique, find I1. This current I1 you have to find out. So it is I1. I1 is the current through 30 ohms. It is a current dependent voltage source. Plus minus means it is a voltage source. It is controlled by I1, where I1 is the current through 30 ohms. So it is current controlled voltage source. So we have to find out I1 using source transformation technique. This is I want to find current in this path, no? So don't to change this, let it be in the same path. This is a practical current source. This is a practical current source. Convert these two practical sources into voltage source. V is equal to IR, Ohm's law. V is equal to IR. 10 into 2 is 10 into 20 is 20. 10 into 20 is 200 volts. Arrow mark side plus. Arrow mark is down. So down plus minus. And here also arrow mark side 50 into 1. Arrow mark side plus down plus here minus. So 50 volts. This is 200 volts. And this will not change. 5I1. Now you have to apply KVL for this path. Kirchhoff voltage law for this path. We can write uh, plus minus. Always current flows from plus to minus, minus plus. This is plus minus, plus minus. Okay, you can apply KVL. Okay, now you can follow any method. So when you're applying KVL, which one is coming first? See, plus is coming there. You can consider plus. Here also plus is coming first. Here also first minus is coming. Plus, plus, minus. You can write. Otherwise, you can write minus 50 into I1. Okay, and plus I1. Next minus 30 I1 minus 10 I1 plus 200, like that. There is rise in voltage, you can consider as positive, fall as negative. So better I am following this method. So which one is coming first I am writing. Okay. So plus 50, I will start from here. Plus 50, different authors uses different. So then this is plus plus 2 minus, no, plus 50. Then again, sorry, this one I wrote wrong. Current always flows from positive to negative, no? So actual current should flow like this. This is minus, this is plus, no? Let me take okay, I1 I'm considering like this only. I1 I'm considering like this only, clockwise only, because I1 is given like this. So irrespective of this, let me write as it is. So first I'm getting 50 plus 50. Again I1 I consider like this now, that is higher potential lower potential. So 50 I1, 50 I1, and this is minus 5 I1, and this is 30 I1, and plus 10 I1, minus, this is first you got minus 200 is equal to 0. I think same thing you are going to get here. This is 50 I1 plus 30 I1 is 50 I1 plus 31 is 80 I1. 80 I1 plus 10 I1 is 90 I1. 90 I1 minus 5 I1. 90 I1 minus 5 I1 is 85 I1. Okay, 85 I1 is equal to 85 I1, and this is plus 50. This is minus 200. Plus 50 minus 200 is minus 150. Minus 150 is this. So you are going to get, according to this equation, 85 I1 minus 150 is equal to 0. That is nothing but I1, 85 I1 is equal to 150. 85 I1 is equal to, this is same as this equation only. I told no, different authors use different, you follow either this method or this method. Last answer will be same only. They are considered here. Okay. This is plus minus 2. This they consider drop, plus 2 minus they considered as minus. They are considering like this end point. So minus is there, minus 50, minus 50 I1 is plus 5 I1, plus 5 I1, then minus 30 I1, minus 30 I1, minus 10 I1, plus 200, plus 200. So that is left to you, how you can consider. So it is I1 is equal to, here also you'll get same answer. I1 is equal to 150 by 85. I1 is equal to 150 by 85. That is the value of current. So we calculated current by applying source transformation. We applied source transformation for converting this practical current source into voltage source. We also applied source transformation. We got simple closed circuit, and we can apply KVL. By writing KVL, I1 is given like this, clockwise. So I am writing like this only. Since I am writing current like this, plus minus, plus minus, plus minus, you have to write. And while writing KVL, I am writing which one is coming first. Plus 50, plus 50 I1, minus 50 I1. This is already voltage value, 50 I1. Then plus 30 I1, plus 10 I1, minus 200 is equal to 0. Or you can write opposite also. All opposite. You can consider minus 50, minus 50 I1, plus 5 I1, minus 30, minus 10 I1, plus 200. In both the cases, you will get the same because this equation throughout multiply negative will give this answer only. So I1 value is 1.76.